65 million years ago, a mass extinction wiped out the dinosaurs, the dominant life form at the time. In this clip, we're going to take a closer look at the causes of this extinction and how it played out. The most likely scenario involves the impact of a massive asteroid. This asteroid was approximately 10 kilometers in diameter and hit what we now call the Yucatan Peninsula in Mexico. The traces of this impact are still visible to this day in the form of the Chicxulub crater. For such an impact to occur, a few conditions need to be met. Most asteroids disintegrate in the atmosphere because of air friction before reaching the ground, so the asteroid has to be large and heavy enough to cross the atmosphere. The speed of the incoming meteor is also a major factor. The higher the speed, the stronger the impact. The gravitational pull of the Earth causes approaching asteroids to accelerate, and their size and mass determine whether or not they reach the surface. A giant asteroid impact generates colossal dust storms and tsunamis when the site is near or in large bodies of water. Massive shockwaves also spread from the site. Before it even reaches the ground, deadly burning radiation emanates from the asteroid. These initial consequences alone can cause the death of many organisms. To give you an idea, the force of the Chicxulub impact was similar to approximately 300 million nuclear bombs. Additionally, the impact causes debris to shoot up into space, generating even more radiation as it re-enters the atmosphere. The initial rapid warming of the entire Earth's surface would likely already be a global killer, especially for larger animals that are unable to take shelter. Plant mortality would be massive. Sea life would be less hard hit at first. However, these events are only the start of the impact. Indeed, most of the massive amount of debris that is generated would remain in the atmosphere for decades, some even centuries. This would cause sunlight to be blocked, cooling the surface of the planet. In the case of the Chicxulub impact, it's estimated that the global winter and total darkness lasted for about 3 years. This cooling and lack of light would be devastating for the remaining plant and animal communities. The death of most plant life means no food for the herbivores, and the death of herbivores in turn means no food for carnivores, causing the collapse or complete change of community structures and compositions. Additionally, sea levels would drop dramatically as water locks up in ice. This would destroy continental shelf habitats, eliminating entire shallow seas, with major repercussions for marine life. It's interesting to note that asteroid impacts aren't the only event that can trigger this type of global cooling. Massive volcanic eruptions are known to have a similar effect. The ash and particles shot into the air during the eruption can act similarly to the asteroid debris and remain in the atmosphere for extended periods of time. Particulates from even a single volcanic event can have a measurable cooling effect on global climate. For instance, the eruption of Mount Pinatubo in the Philippines in 1991 cooled global climate for years after the event. An eruption big enough to produce amounts of debris comparable to the impact of an asteroid would have a similar effect on climate. In the case of dinosaurs, since they were cold-blooded animals, the drop in temperatures meant massive mortality and eventually extinction. Smaller organisms and omnivores able to feed on a wide range of food would be the most likely to survive the impact and the climactic turmoil that followed. And indeed, after the Chicxulub asteroid, small mammals became the most successful life form. This was the start of a new era, which eventually gave rise to all modern mammals, including our species.